Hello students, welcome to this video. In this video we are going to solve grade 10 mathematics question from real numbers. It's an application of LCM. So this example is not very well explained in the class or not even by the coaching centers. The question is, find the smallest number which when divided by 28, 32 leaves remainder 8, 12 respectively. So to reduce the length of the video, I have already prepared the solution. So I will just go through what I have written. We want to find a single number. So we want to find only one number which when divided by 28 gives remainder 8, and the same number when it is divided by 32 it will give remainder 12. So the approach is, first we will find a number which is totally divisible by the both 28 and 32. So the totally divisible means the remainder will be 0. Obviously that number is the least common multiple of those two numbers. So this is our routine work to find LCM. LCM is 224. So 224 is a number which is completely divisible by 28 and 32. This is our traditional division. We can see the calculation. 224 when we divide it by 28 we get quotient as 8 and remainder is 0. Same with 32, quotient is 7 and remainder is 0. So here I have a small explanation which will clarify the theory behind or the process behind solving this question. So let's begin the explanation. So 28, the quotient is 8. This means that we have 8 bunch of 28 objects. Okay, so these are the dots. So 28 dots, 28 dots in the second bunch. So like this we have total 8 sets or 8 bunch of 28 objects. So total how much we have in this 8 bunches is 28 8s. Okay, so 28 8s is obviously 224. So from the first set till the 8th set there are 224 dots. So 224 objects and there is no remainder. Got it? So there is no extra object left over in the new set. So this is the meaning of remainder 0 in this. So there is nothing in it. The same explanation goes with 32 dividing 224. So we have quotient is 7. So we have 7 sets or 7 bunches of 32 each object in 32 object in each set. So like this we have 32 7 32 into 7 224. Total we have 224. There is not a single object left in the extra set. So remainder is 0. So I hope we understood what's the meaning of this our traditional division. One more explanation. Since there is not a single dot or a single object in this, so remainder is 0. Let's move further. Now we want remainder 1. Okay, so obviously I will be adding 1 dot in this extra and one dot in this extra. So these extra dot 1 will act as a remainder equal to 1. Okay, let's see. So I have if you want remainder 1 in each division, I'm going to add 1 extra dot in that blank set. So one dot over here and one dot over here. So this is the addition of 1. Okay. So originally we have 224 dots. We added one more. So this results in 225. So division goes like this. 225 divided by 28. So 28 eights are is 224, remainder is 1. Similar cases with 32. So what is that number? So that number, that dividend is 225. In this case, we have one unique number, 225, which is acting as a unique number for the both divisions. So the first is division by 28 and the second is by 32. So we have one answer in this case. So this explains obtaining the remainder by adding extra things, okay? Adding 1. Now, one more explanation just to check. If we want remainder 19 and in the both division, and by adding extra objects in the blank set, so how many I need to add? So I want remainder 19. Going to that diagram, I will be adding 19 extra dots. 19 extra dots in this and 19 extra dots in this. This is again by addition. So how it goes? So I'm adding 19 to this and again 19 to this. So what is that number? 224 plus 19, 243. So this number is 243. So 243. So again, if you execute this division by 28, the closest number smaller than this in 28 tables is 8s are 224 minus 19. Remainder is 19. So same thing is going to happen over here, 90. And what is the number? 243. So again we have a unique solution. We have a unique solution for the both division. Now here's a important explanation. All these two explanation were related to adding extra objects in the extra blank set. Now I want remainder 1 in both division, but this time by subtracting. So we have to pay attention for this. I want remainder 1, but this time I don't have this extra blank set, so that I'm not going to add this time, okay? So what I have is the last 8th set, where I have 28 objects or 28 dots. I want remainder 1. So what I will do, I want remainder 1, so I have to remove everything from the last set except 1. Just tell me how many dots I have removed. So I have removed, earlier there were 28, and I have removed 27 dots. Okay, so I have removed 27 dots. But how can I get this 27 by using 28 and remainder 1? So the relation between these three numbers is whatever the divisor is and whatever the remainder you want, you just subtract it. So 28 minus 1, whatever the answer is, 27, you just remove these many objects from the last set. Okay, so in order to achieve the required remainder, in order to achieve the required remainder, you have to subtract the same remainder from the last set. So last set contains 28 and you want remainder 1. So subtract it, you will get 27. So these many dots will be removed and you have only one remainder. So I hope this is clear. So 28 minus the required remainder. So here the remainder is same 1 in both case. So it will be removed from 32 also. How many dots I want to remove? So there are 32 dots and you want only one. And you want only one. So tell me how many dots you have removed. 31, right? So 32 minus 1. These many dots you have to remove. So that is 31. Okay. What's the general idea? 32 minus required remainder. Okay, I hope this is clear. So let's remove it. Let's keep only one dot in this and execute this division. So how many dots I have removed? I have removed 27 from this. So 27 from this and 31 from this. Remainder, let's see what happens over here. So what is this number? So 28 224 minus 27, 197. So 197. Which number is closest to 197 in 28's table? So I have disturbed the last set. So I can reach till 28 sevens. So 7 over here. And what's the value of 28 sevens is 196. So here we have 196 and the remainder is 1 and the quotient is 7. So 7 full bunches of 28 objects. So what's the number? Number is 197. Let's work for this. 32, I have disturbed the last set, so I can take 32 6a. 32 6a, okay? 32 6. So let me write over here. Okay, so I have to remove 31 from all 224 dots. Okay, so 224 dots minus 31 is 193. So 193. And who is dividing? 32. So 32 6a, right? So I have these 6 sets totally intact, not disturbed. So what is 32 6a? 32 6a is 192. Remainder is 1. Remainder is 1 and this number is 193. So this is 192, remainder is 1. I hope this is clear. The point, the catching point over here is the number same? No, the number is not same. So here we don't have a unique solution for such type of remainders where 28 minus r and 32 minus r if they are not equal. If they're not equal, we are not getting the unique solution, but we are getting two different solutions. This can be explained further. Um, why we are not getting a unique solution, that this totally depends on Chinese remainder theorem, which is totally out of the syllabus of grade 10. Chinese remainder theorem, or if we know Diophantine equation like this, ax plus by equals to c. This is also coming from Chinese remainder theorem. This has a unique solution if and only if HCF of a comma b divides c. This is not going to happen over here. That's why we are not getting a unique solution, but we have two different solutions. Okay. Let's not confuse ourselves with very different things which is not in our syllabus. Let's concentrate what's happening over here. So 28 minus required remainder, right? These many things have to be removed from 220. Who is 224? This is LCM. So I'm removing, so we are removing 28 minus remainder from the LCM. Okay, 32 minus remainder. These many objects, that is 31, is supposed to be removed from 224. And who is 224? LCM. Eventually, you will say like this: LCM minus divisor minus remainder 1 and minus divisor 2 minus remainder 2. Like this. Let's see how it is going to happen. Okay. One more example. If we want remainder 19 in both cases, in both division, and again by subtracting. Now let's check what we have learned. I want 19, but this time I want to remove how much I want. I want 19 dots in the last set. So how much should I remove? 28 minus remainder, right? 28 minus 19, what is it? 28 minus 19, 9. 9 dots will be removed. Let's say I have removed 9 and these are the 19, okay? So 9, from where I have removed 9? From total number of objects or dots. So 224 minus 9. In this case, in the 32 dots case, 32, I want to keep 19 dots in this. Why 19 dots? Because it's the required remainder. Suppose I have, how many dots should I remove? 32. I want 19, so 32 minus 19. 32 minus 19, 13, right? So 13, you have to remove 13. But from where? Total 224 may say you have to remove 13. Okay. Let's fill the blanks over here. Okay, so I have to remove 9 from here. I have to remove 13 from here. What are the numbers? 224 minus 215. So this whole calculation is 215. And who is the nearest number to 215 in 28 stable 28 sevens are? I hope this is clear. 28 sevens are 196. 196 minus 215 is remainder 19. Let's ignore this negative 19. Okay, so remainder is 19. 196. So quotient is 7. 32. How much I have removed from here? I have removed 13. So let's say 13, and these are the 19 dots. Okay. So 224 minus 13. The number is 211. So the number is 211. This calculation is 211, and I am dividing 211 divided by 32. Who is the closest number to 211? It's obviously 6. 32 6. 32 6 is 192. So here we have 192. So 192. Subtract it from 211. 211 minus 19. So remainder is 19. So that negative is because I am subtracting bigger number from the smaller one. Let's ignore that negative. Again, is the number same? No. So we don't have a unique solution in this case because the Chinese remainder theorem. But I hope the explanation is clear, and this will be taken further for explaining the main target. One more explanation. If we want now we have two different remainders, and the method is by subtracting. I want 20 in the one division and 16 in the another one. So tell me, here the last set contains 28, but you want only 20. So how many so these are the 20 dots. How many you are removing? So you want 20. So how many you will remove? 28 minus 20. So you will remove 8. Okay. So 28 minus remainder. You have to remove this. So 8 will be removed. 8 are removed. So total 224 में से 8 remove करना है. So remove it. 216. 224 minus 8. 216, and remainder will be 20. What I am doing? This is wrong. So this is 216. 28. Obviously I have disturbed the last. So 7s are 196, I guess. 224 27. I'm doing it again. 28 into 7. 196. How many times I have did this? Okay, so subtract it. You will get, this is 216. Remainder is 20. Okay. And what about this 32? So 32 minus remainder. These many dots you will remove. You want remainder as 16. So 32 minus 16 is 16. So just remove 16 from this, the last set. And the leftovers are 16 dots in this. How this division works? So you are removing 16 from this. Two to 4 minus 16 208. So the number is 208, and the closest number is 32 into 6. 32 into 6, 192. Just subtract this from 208. 16. Okay, so remainder is 16. I hope this is clear to everyone. Okay, so the generalized way to this process is 28 minus remainder 1, 32 minus remainder 2. These many dots have to be removed from 224 minus 28 minus R1. So 224 minus 8. So this is LCM minus 28 minus R1. So again, so here the same thing, LCM minus 32 minus R2. Coming over to the question. Now, these are the remainders that we want in our main question. Something good will happen in this part, and that part is the removing the dots that we are removing will be equal. Now I want remainder 8 in the last set. Let's say these are the 8 dots. So how many I have removed? How many I have removed? So I want 8 dots. So out of 28 minus 8, so I have removed 20 dots, right? I have erased 20. Now in the second case, I want 12. I want to keep 12. So how many I am removing? 32 minus 12. So what is it? 20. So remove 20 from both things, okay? So 224 minus 20. 224 minus 20. Okay? So what's the number? The number is 204. 204. The number is 204. Now tell me, do I need to fill this? This is so, I have repeated this so many times that it's a routine now. I hope the idea is clear. So 224 minus the divisor minus the remainder. In this case, this quantity was same. That's why the required number is LCM minus the difference D minus R. Either you take the first divisor or the second divisor, it doesn't matter, because the this quantity is same. Okay, and we have a unique solution over here. In all the above examples, the uniqueness was not satisfied. Okay, 224 minus 8, the number was 216. So these two are two different things. This is a totally different part. The good thing here is we are getting the same number after removing the dots. Okay, I hope this is clear to everyone. Just go through this again and apply whatever you have learned from this in different types of questions. I hope this explains everything, the theory in detail, why we are subtracting the difference from LCM. So this is the smallest one, smallest number, which is divisible by 28 and 32 to get the remainders 8 and 12. So 224 minus 20. So this 20 is luckily the unique for the both cases, D1 minus R1, D2 minus R2. Otherwise, the uniqueness is not satisfied. You will never get the unique answer if we have these two quantities different. ये दोनों सेम होने ही चाहिए, तभी चाइनीज रिमाइंडर थ्योरम, डायफेंटाइन इक्वेशंस का एग्जिस्टेंस ऑफ सॉल्यूशन सेटिस्फाई होगा. आई होप ये एग्जाम्पल काफ़ी हद तक क्लियर हो चुका है. आर एस अग्रवाल, आर डी शर्मा में ये या इंटरनेट पे कहीं पे भी देखेंगे तो दे आर जस्ट मेंशनिंग LCM minus k. This k is this value. And the students are confused why we are subtracting from it LCM. तो अगर हम इसको ध्यान से देखें तो ये कोई इतना हाई फाई चीज़ भी नहीं था कि हमें समझना आए. ये टोटली ट्रेडिशनल वे ऑफ डिविजन पे ही मैंने ये पूरा निपटा दिया एक्सप्लेनेशन. So this is all from my side. I hope this is clear to everyone. Thank you everyone.